Hello, everyone, and welcome to today's webinar. Thank you for joining us. My name is Julio Memba, and I'm very excited to be your host for this session where I'll introduce you to an innovative technology that is a game changer in the UAV industry. This session is going to last around 25 to 30 minutes and is going to be divided into two parts. The first one, I'll explain you all about this technology and how it works. And in the second part, I'll try to answer all of your questions. So during my presentation, if you have any question, just write it down on the chat window that you see below. Okay, so let's start. Today, we will discuss the GNSS-Denied Navigation Kit, a product that enables the navigation in UAVs when the GNS signals are not available. That means that you are going to be able to navigate with high precision without using satellite signals. As you already know, the current geopolitical situation has underscored the needs of UAVs that are able to reach from point A to point B no matter what. And I'm not just talking about military operations here. I'm also talking about civil operations where nowadays the authorities require from you to keep control of your aircraft in different scenarios and situations. So, answering all those needs, the GNS Denied Navigation Kit was designed. So, what's in the kit? Well, the kit is formed by two elements. The main element is the Polar 300, an attitude and heading reference system, and then we have the VNS, the Visual Navigation System, that is connected to the Polar 300. And let me tell you something. When we combine these two guys together, their performance is impressive, as you will see in a few minutes. Okay, what else is in the kit? The kit also includes a breakout board for lab testing, this one right here. And below this panel, you will find all the wires and connectors needed for a quick and easy integration process. So let me explain you what each of these elements do in the kit. Okay, so the Polar 300 is one of the most valuable assets within the company. I already told you that it's an attitude and heading reference system, but it's much more than that. It also includes an inertial navigation system, an air data system, a GNS module, and can be used as a SATCOM on the move terminal. So it's a very complete device that is not only an essential part of all of our autopilots, but also we offer it as a standalone solution. So customers all over the world that they have their own autopilot system, they use the Polar 300 because they know and they trust in its performance. And I'm not going to go into all the details of the different features from the Polar 300, but I want to focus on three of them that are going to have a big impact on the purpose of this kit. First, the Polar 300 state estimator is reliable, precise, and robust. And if you want to build a navigation without GNS, a reliable state estimator is the foundation. Second, depth reckoning capabilities. The Polar 300 is going to be able to navigate without using GNS signal. And I'm not talking about using the visual navigation system, just the Polar 300 with its own sensors. You can expect something around 35 meters per minute, and that is in the worst case scenario. In a proper calibrated platform, you can expect lower than 20 meters per minute. And third, the Polar 300 is going to be able to detect even the most sophisticated spoofing attacks on the market. And this is crucial because it doesn't really matter how many safety features you have if someone can get control of your platform with the spoof GNS signal. And that is something that you don't have to worry about if you have a Polar 300. Okay, so now that I think you understand the importance of these three features, let me introduce you to the VNS, the Visual Navigation System. It's also a very small and compact unit. It only weighs 100 grams, and you can place it anywhere you want in the aircraft, as long as it has a clear view below. It has its own memory. It also has its own CPU. And as you can see, it has a built-in camera that is going to use to continuously take pictures. And it's going to be applying two different techniques to these pictures: visual odometry and pattern recognition. And applying these techniques, to the navigation without GNS is going to increase the performance to a whole new level. Let me explain you how it works. Basically, there is going to be two different modes. One is when we have GNS signal available, and another is when we don't. So when we have the GNS signal available, the system is going to be continuously taking pictures, tagging them with the coordinates that is getting from the GNS, and storing those images in an internal memory, creating an internal georeference map. Okay, let me explain it one more time. So if we have a GNS signal, the aircraft is going to be flying, taking pictures, tagging them with the coordinates from the GNS signal, and storing all that information, creating an internal map. Okay, so that map will be used later on when we don't have that GNS signal available. Okay, so this is the first mode when we have GNS signal available. Then we may go under a jamming or a spoofing attack that will be detected by the Polar 300. And then there are two different options. One is that we are in a known terrain, in a place that we have been flying there before, and therefore we have an internal map, an internal georeference map available. Okay, so in this case, basically the system, what it's going to do is going to also be taking pictures, but this time it's going to be comparing all those images with a pattern recognition technique with those that were previously stored on the internal memory. And basically, with this technique, the system is going to be able to close the error in position, and basically you won't have any drift. Okay, but then there is another option, that we are in an unknown terrain, a place that we never been there before, and therefore we don't have a map available. So in these conditions, we are going to use two techniques: visual odometry and pattern recognition. So the visual odometry, this time, the system also is going to be taking pictures, but this time is going to be looking for singular points on each of the frames. Okay, what is a singular point? A singular point depends on your flying altitude, maybe a rock, a tree, or a mountain. Depends on how high you are flying. So the system is going to be looking for singular points, and it's going to follow those singular points through consecutive frames. So it's going to know the displacement and direction on each one of them. Okay, and also we are going to combine this technique with the pattern recognition. Okay, and let me remind you that in this example we are flying in an unknown terrain, we've never been there before, and we don't have a GNS signal available. Okay, but also we are going to use pattern recognition. We are going to be taking pictures, tagging them, and storing them on the internal memory. But I know what you're thinking. Okay, what are you tagging them with if we don't have a GNS signal? Okay, this time we are going to be tagging them with an uncertainty value, because yeah, it's true, we don't have a GNS signal, but I told you that the Polar 300 is really good estimating its position. So that is exactly what we are going to do. We are going to tag in them with the uncertainty position, and this is going to allow the system to be able to create a whole new map in an unknown terrain. And this, in combination with the visual odometry, basically is going to allow you to fly in an unknown terrain over extended period of times with a really small error. In the worst case scenario, will be less than 1% of the distance travel. Okay. So now I think I explained you all the operational modes. Let me just review it quickly, go over them just one more time. Okay, so there are basically two modes: when there is GNS available and when we don't. When we have GNS available, we are going to be taking pictures, tagging them with the coordinates, and creating an internal map. When we lose that signal, there is two different scenarios: that we are in a known terrain, we have an internal map available, and basically you can expect no drift at all. Or then we can be in an unknown terrain, we've never been there before, and we are going to use visual odometry and pattern recognition, tagging those images with an uncertainty value, and we can expect less than 1% of distant travel. Okay, so let me explain you more into details how this is working. Okay, in this example, we have an aircraft that is flying at 120 meters altitude. Okay, so in this example, the footprint of the camera is 50 by 50, and you see the red squares represent the images that we have been taking during the flight. So whenever we fly in this area, we are going to be able to use this map. Well, not always, as long as we fly in a similar altitude, okay? Because, well, in this picture, we are flying at 120 meters altitude. But what happened if we come back to this area and we are flying this time at 1,000 meters above ground? Well, obviously, we won't be able to use the same map because of different scales, okay? But then we have another feature is that the system is going to be able to store different layers of the same location at different altitudes, and automatically the system will choose one or another, depends of how high it's flying. Okay, so how the system is going to know which altitude, which map to use? Well, it's a simple formula. It's going to be the current altitude multiply and divided by 2. So in the example that I just gave you, that we were flying at 120 meters altitude, you are going to be able to use that map as long as you are flying between 60 to 240 meters. Okay. Also, the system is going to follow a smart mapping algorithm that is going to ensure that we are going to have more than one image of the same location. And yeah, but probably some of you think like, okay, but is that efficient? We do really need to do that? Yeah, the answer is yes, because um, like this, we are gonna for sure we know that we are gonna have more than one layers of the same location. And let's say like we have been flying for I don't know 7 or 8 hours, and we need to free some space from the memory, but probably we don't want to lose our all information. Okay, but we need to free 10% of the memory. So how the system is going to do it? Okay, it's going to erase 1 out of 10 of the images, but as the system has many layers of the same location, if we just pick the lower picture, we basically we are going to keep as much area as possible. Okay, next question. Okay, how big is the memory? So in the most demanding conditions, you're going to be able to fly for more than 10 hours of flights, at least 10 hours. And I'm telling most demanding condition, what is that? Okay, so if you're flying pretty fast, like 200 meters per second, and very low, you need to take a lot of pictures. Okay, so in that situation, the memory will be full sooner. So in those demanding conditions, you're going to have at least 10 hours of flight. Probably in a more real scenario, you're going to have much more than that. Okay. So I already told you about the performance. I already mentioned several times, but let me just go over it one more time. Basically, there is going to be two different scenarios. One, that we are flying in a known location, in a known area. Okay. So when we take off, all the area that is surround us, that we know that we have been there flying before, is a known area. In that area, we can expect to have no drift. Basically, the same error that we had when the picture was taken and was tagged with the GNS signal. So basically, we can expect the same error that we had on our GNS at that moment. Okay. Then there is another scenario in which we are flying in an unknown areas. And as I already mentioned, in the worst case scenario, we can expect less than 1% trouble. But let me give you another example. We like with this combination of techniques, visual odometry and pattern recognition, we are going to be able, for example, to perform surveillance operations in where we take off and we go to an unknown area. We don't have GNS available, well, but we want to perform a loiter maneuver for unlimited time, and you are going to be able to do it with no drift. It doesn't matter if you stay flying like that for many hours, you won't have any drift at all. even if you are on an unknown terrain without GNS, okay? And then there is the third possibility that basically is a combination of both, that we are flying. This is very common, that we take off from our known location and we go to an unknown area, okay? So basically it's gonna be a combination of both performances. Okay, so let me talk to you about the limitations of the system. But just to be clear, now I'm going to mention the limitations of the visual sensors, not the kit. Okay, the kit is going to be able to navigate without GNS signals in all the different scenarios. It doesn't matter if you fly a day and night, it doesn't matter. You're going to be able to use it. However, the visual navigation sensors, they have some limitations, which are the first one, we use a daylight camera, so you cannot use the visual sensors at night. Then also, if you fly pretty high over clouds, you are not going to be able to use the visual sensor for obviously reasons. Also, the last limitation is if we are flying over the sea, also the visual sensors won't apply. Okay, so this is basically it. I hope you like it. And now I'll try to answer all of your questions. Okay, so the first one from Dieter. Okay, so hello, I would like to know if external maps can be loaded into the VNS obtained by other means beforehand. Okay, no, the answer is the system does not allow to load any external map. The GNSS-Denied Navigation Kit does not have that limitation. And why I say that? Because if you are going to load maps, you depends of two different factors. One, that you need to have a very updated map before every operation, and that is not easy to get. And second, if you are going to use an external map, you're going to need to fly probably over 500 or 600 meters, and that is something that our customers they don't like it right now. Okay, also Kevin, do you have the capacity to manufacture and deliver this navigation system in large quantities? Yeah, no doubt. Yeah, it's something that we actually do. How long does it take to have some test units available? Well, for all of you, if you want to have test this technology and want to involve in more serious conversations, you have the contact mail below the window. So just send us a mail and we'll get in touch and we'll start the conversation for you to test this technology. Okay, more questions. What is the maximum altitude at which the system can operate? Well, there is no limitation. As long as the camera is able to see the ground, you're gonna be able to operate. As I already explained you, a singular point may be a rock, a tree, a mountain, depends on how high you're flying. If the camera sees the ground, you're gonna be able to use it. Okay, so I think there are no more questions. So thank you, everyone. I hope I have clarified your questions. And however, if you have any doubt, any question, please get in touch with us through this mail, and we'll be more than happy to help you. Thank you very much. Bye.